Hey, wanted to make another demo and instructional video on, it's basically another variation on the video I did the other day with an integration between an SDR Panadapter and your HF rig. And in this case I'm using SDR console, and I'm going to have multiple apps running. I'm going to have the Panadapter as SDR console, and then I'm going to have n1mm for logging and rig control. So what we've got here is the ftdx3000 is running the show, and we've got n1mm logging, and we've got SDR console and an SDRPlay RSP1A, and it's connected to the RX out port on the back of the Yaesu. So this works really, really well, and I wanted to show a demo of one of the really useful features about this. So what we've got here is a de-expedition station. J38R is in Granada, and you can see the pileup off to the right. I'm listening to the calling station. So what's really interesting about this is that you can run split. So I'm listening to the caller. I've got VFO-A locked in place. I'm going to switch my TX, and then I can scroll up and down the pileup with my TX frequency. So what we can do is listen, and when he calls a station, we can try and figure out where he is in the pileup and kind of use this as a visual reference as well. Let me wait until he calls another station. I didn't actually expect to get him there. I've already worked these guys on 15. Nope. Anyway, you get the idea. This is really, really useful. Alright, so let me go back to one VFO. I've demoed this before on the other radio. Got the point and click functionality. Let me unlock VFO 1. And of course we can scroll around with our VFO. We can throw a frequency in here. 20. Radio follows, and so on. Really, really useful feature. So let me get over here out of the way so we can talk about how we accomplish this. Alright, so there's a couple different components here. Let me turn all this stuff off. I'll explain how we do it. Alright, so for starters, we're not going to be splitting ports. We're going to be using the radios, just the standard COM port. Okay, so we need omnirig. SDR console is going to communicate with omnirig to draw the frequency information and feed frequency information into the ftdx3000. So here are the settings that I use for the ftdx3000. You can pause the video, take a screenshot, whatever. They're pretty straightforward, just like you would set it up for any other app. Okay, and then for SDR console, we have to select our receiver. In this case, I have two different SDRPlay receivers. Note that I am not using a converter or inverting the spectrum, because on the ftdx3000 I'm just using the RX out port. It has an IF out port as well, and if I use that, I think the IF frequency is like 9 megahertz. Then I would have to use a converter to make it work. But it's kind of a nice feature to just have the RX out. And the RX out port on the ftdx3000, when you switch into transmit mode, is switched out so you don't fry your SDR receiver. So let me start this thing. Alright, now on top of that, when you set it up initially, you have to go to the view pane or the view tab, and then in more options, select, and you want to allow an external radio. Okay. No, we don't want to restart it because we've already done it. Okay. So then you bring the receiver in. Once you do that, you restart the program, and then what will happen is you'll be presented with this additional option here for an external radio. And it communicates with omnirig. We've already got that set up. This is good. It shows the rig is online. Antenna is the same frequency as the external radio. I didn't touch any of this other stuff. I already had the appearance set up. You don't have to select any serial ports. It does that automatically. No up converter. Alright, for the transmit, I want to mute the audio. This is for the SDR receiver, and reduce the IQ data by 80 dB. This way you don't get a big blip on your SDR screen. It's a nice log file so we can debug if we had to. Okay, everything's good. Now I want to track the radio. Okay, it was already tracking. If all that works, you should be able to click on a frequency and your radio follow. Okay, now what's different about this from the last video that I made on this, last time we used a port splitter and then we set up a logging program just as you normally would. The only difference was we were looking at the split port instead of the original port. This time, I tried that setup with the ftdx3000 and it didn't work well. There was it was shifting back and forth between the frequency that the VFO was on and some other, it was like 12 megahertz or something. I'm not sure where that was coming from. But I have found that this works well. So in this case, what we do is we're going to feed the information from SDR console out into our logging program. So in order to do that, we have to create a virtual COM port. And what this is basically a pipe from one COM port to another, and you can feed it in, you can feed information from one program into it and have another program subscribe to the outbound information. So in this case, we're going to use com0com, and all I did was just create a pair here, named them some unused port number, and add the pair and apply it. I've already got them going. So all right, so what we're going to do is we're going to feed the logging information or the frequency information from SDR console into com0com, and then we're going to have our logging program look at com0com to get its information from this virtual port pair that we just made. So in order to do that, you need to find the all options. So all I did was just, let me do that one more time. I just hit view, doesn't matter where you get it. You want to just bring up the options menu, and then I hit show all options. Okay, so what we're looking for is controllers, cat and serial, and this will show you all of the COM ports that are available on your machine, and then here are the these are the two virtual ports that I created. So what I want to do is use COM port 12, and it's very important that you set the baud rate. It defaults to 57600, so you select your port that you want to use, that you want to feed information into, set the baud rate, and that's pretty much all you have to do. Now let me open n1mm. If you look in the details here, it uses the Kenwood TS2000 protocol. So when you set it up in n1mm, the trick is that you have to look at the output port from the pipe that we created. So we'll be using com13. We're feeding com12, and we're going to be subscribing to com13. And the trick is to use to make n1mm think that your radio is a TS2000, because all the communication between the two programs is going to be in the TS2000 protocol. So, because if I've already, let's see here, if you can see right here, n1mm says TS2000 VFOA. Alright, config. Okay, so what I did was I set up my com13 and set it up as a TS2000, set all the port settings. That's all you got to do for the frequency and the readout. Now to send CW, normally for the ftdx3000 it has two different COM port interfaces. One of them is enhanced and one of them is standard. You use the enhanced port to handle all the frequency information, and you use the standard port to send CW. And I've got DTR sending set it up on COM port 6, since COM port 6 is not being used for anything else, and it works great. Okay, there we go. You can send CW. You can type in a frequency. We're all set. Alright, so again, the software I used for this was SDR console, n1mm for the logging. To do the null terminal or the virtual COM port, I used com0com, and omnirig. Also used omnirig to be able to communicate between the radio and the SDR program. Thanks for watching. If you have any questions, throw them in the comments. Thanks.